We're going to have some fun today doing the 2021 mechanical lighting as they pertain to the residential aspect of all of it. Now, I believe that we have hit just about all the other components out of the code. So now we're going to finish up with all the fun residential is going to provide for us. So, since we're going to talk about residential, here is the first question of the day. When is a residential project a residential project? And I made sure to ask the question as everybody took a bite of their food so that, you could all have an excuse as to, my mom told me not to talk with my mouth full. Anybody? When is a project considered residential?
3 stories or less.
All right, so the energy code, and this is the only definition or for the energy code, it only pertains to components of the energy code. It considers residential as single family, 2-family, townhouses, R2s, R3s, and R4s that are 3 stories or less above grade plane. So that means anything else is considered to be commercial. Now, what that entails or what that does do for us is there may be opportunities that the project may have been designed to the IBC, but you're going to apply residential energy to that IBC building. Any questions about that? Now let's have a little bit more fun. What do we do when a building is a mixed-use building? So if we have a building that's 3 stories, bottom floor is commercial because it's a coffee shop, it's a bakery, and then the next 2 stories above it is residential, we get to take the entirety of that book, both front and back of the book, and apply it to the various levels of that structure. So the bottom floor, being our commercial, is going to look at the first half of the IECC, while the upper 2 stories is going to take a look at the back side of the book in that. Any questions on this? All right. This, and don't forget, just because I mentioned, story above and story below, especially when we're talking about residential projects, there's an awful lot of multifamily going in. They may not be going up. Sometimes they're going out because they can't go above a certain height. All right. So, as we mentioned today, part of what we are talking about is dealing with HVAC and lighting. Focusing on the HVAC, there's obviously a lot of reasons why we want to ensure that we have a very well-designed HVAC system. We've spent a lot of time talking about the thermal envelope and how the thermal envelope is working with everything and ensuring that the design happens. A lot of times, especially when we are talking residential, the mechanical side of things aren't necessarily thought of, because how many of you actually get outside of maybe a manual D for a residential project any mechanical information? Anybody getting anything beyond a manual J, S, and D? Not typically, right? So there hasn't necessarily been a strong focus on that, but if you look at the provisions that are in that section, they actually have some significant provisions and requirements for the mechanical compliance. So there's some things that we need to know about that. Now, the reality is when we're doing all this, obviously the big aspect of the mechanical system is what? If you're a builder, you're thinking about, I want to make sure that the occupants are comfortable. And so does the energy code. But the energy code takes it a little bit further and says, hey, you know what? We also want you to do heating and cooling load calculations to ensure that the equipment that's going to be installed has been sized to what those loads are. So the idea of all of that working together is to ensure that there's comfortability within the system itself for the occupants. It's also a great way of being able to control humidity. And a lot of that, depending on things like ERVs, HRVs, things of that nature, it really can improve the air quality that's within the structure itself. So let's kind of dive in to a little bit of not necessarily the building science behind all of this, but really why we care about having all of this, ensuring that we have those residential mechanical systems kind of working for us. And so there's a lot of things that we have to think about there when we're talking about the comfortability of what we would have for those occupants, right? Because that structure itself, right, this building has a lot that it has to encompass, right? It has all these forces that are weighing on it, right? Oh, sorry. And so we have to think about, you know, heat conduction, radiation from the sun, right? How much radiation is solar heat entering into the structure as opposed to reflecting away from the structure? And then the convection that's kind of happening within everything. So there's a lot of things that these mechanical systems are really trying to combat to ensure that not only are the occupants comfortable, but it's also an energy efficient system and structure itself. So with that, we're coming to the most favorite section that Hope talks about all the time, which is 103.2. 103.2, no matter where you touch the project, whether you are designing it, whether you're reviewing it, whether you're building it, or whether you are inspecting it, this is the most important section in there. And that's because this is a list of all the items that must be placed on that construction document. So when we take a look at, oh, it didn't do it. Okay, so when we take a look at what we have for mechanical and lighting, we have a few things. Number 5, mechanical system design criteria. That's something that we're going to want to ensure we have. A lot of times when we're talking straight up residential, like single family residential, and not necessarily, you know, in our 2-3 stories or less residential, typically your mechanical system design criteria usually comes up on a Manual J. Now, while this section says everything must be placed on the construction documents, in this particular instance, I'm okay with it actually being placed on that Manual J for now. When we're talking commercial, this should also be placed on the plans, and it typically is. Now, mechanical, service water heating systems, equipment types, sizes, and efficiencies. Again, do we typically get this information on the construction documents? In a traditional, what we would think residential, single family, 2-family townhouse? If we're not getting anything really for mechanical plans, how do we know whether a project that works? These are all things I'm going to have you think about as we move forward. We'll come to the answers. And then controls, right? We know the energy code is full of controls because we are a code book that has control problems, right? The next one is our duct sealing, duct and pipe insulation, and their location. Now for this, I will say typically duct sealing, maybe not so much, but their location I would get in a manual D. The information I'm not getting a lot of is anything talking about sealing, duct sealing, which we'll talk about here shortly, but typically when that comes up, a lot of people just say that's a field verification item. And then duct piping insulation and their location. Again, I don't see it very often originally put on the plans. If it's a plan that comes to me, I can guarantee you I make them put those notes on the plans so everybody's aware of it, especially if they have those ducts and piping that's going to be outside of the thermal envelope, they're going to put that on there. If it happens to be that everything's inside the thermal envelope, then I don't worry about that other than the duct sealing. But I do want this information placed on the plans, and it should be in accordance with all the information that we have here. So let's kind of run through all of the fun and excitement, bless you, that we have within 403 and move through 404. But 403 to start off with, we have to have a thermostat provided for all of our heating and cooling systems. So for each of them, we have to have one. So if you have a thermostat, or I'm sorry, 3 heating and cooling systems, you need at least 3 thermostats, right? So we can't just have a single one. Now, having a thermostat, it now has to do a lot of really fun things. It's not all that outside of the realm of things, but now it's got to be able to maintain a daily schedule, and that daily schedule has to have different temperature set points. It has to have the capability that it has different times of day, right? And that's typically like, hey, I want the temperature at 70 degrees at 6 when I wake up, but from 8 to 5 when I'm not there, it doesn't have to be as warm, but when I get back, I want it comfortable, right? So it has that ability that you can do that. It also needs to have the ability that it can do different days of the week. And that's because most of us work, right, Monday through Friday, and we're off Saturday and Sunday. And so the idea is that you have the ability to set your thermostat to whatever kind of your lifestyle is. So if you work Monday through Friday and you're home all day Saturday and Sunday, then you might leave it at a more comparable temperature on Saturday and Sundays while you're there. Or if you work, Wednesday through Sunday, then Monday and Tuesday might be the day that you have it set up. So it's not set that Saturday and Sunday has to be that way. It's just giving you the ability to set it up that basically works for your lifestyle. Now, there are some criteria that does talk about the thermostat must be capable to set back or operate between 55 degrees and not greater than 85 degrees. That's typically something that's kind of addressed with the manufacturing, right? The manufacturers ensure that it can't, basically what they're trying to say is you can't require that the thermostat only work from 70 to 75 degrees. It has to have the ability that if the person wanted it to go all the way down to 55 or all the way up to 85, that it can do it. Now, the next bullet point is talking about how the manufacturers set all of this up initially. And so this criteria isn't necessarily something that we would look at. It's one of those, again, hey, by the way, manufacturers do X, Y, Z type of deal. Any questions about the thermostats? Yeah. Oh, okay, yes.
In-floor heating, pushback about setbacks.
Okay, so in-floor radiant heating, that happens to be one of those situations that you have to remember the energy code tries to take a very broad spectrum of criteria and try to fit as many into that. When it comes to that situation, it doesn't always work. So I do know of some locations that kind of ask that basically you submit an alternative method means and material, and they do accept that, understanding that that's the limitation of how the thermostats work with that radiant floor heating. But you're right, there is an issue with that. In fact, the state of New Mexico, I believe, amended that criteria out for the radiant floor because of the issue with it. But I could be wrong on that. I know there was a lot of discussion on it. And there was another hand. Yes?
That last bullet point, that
Uh-huh.
would get overridden if the jurisdiction has different set points that they require, right?
So this is the initial one. So basically what they're ensuring, because there are, when they go in and they program the set points, they can adjust it differently. This is basically saying, so manufacturer, when you originally do it, to ensure that we have some sort of standardization of setbacks, just in case nobody goes in and changes it, this is what the initial is.
So if the jurisdiction says that you have to cool to 75 and heat to 72,
Then,
wouldn't matter, you would still have to set.
and because this is at the initial manufacturer. So the manufacturers, as they're producing it, that's what they produce for the product. Now, when the contractor or whoever takes it and installs it, they're going to install it per whatever your ordinance is going to say. Absolutely. By the way, I didn't put that slide in here, but I love questions. It's a great way of learning, so always ask your questions. All right, so we had a little discussion. Does this type of system work? Does this count towards what this is requiring? Because here's the reality. When this was put together, a lot of these apps were not necessarily in the marketplace, right? And you have to remember, even though this is the 2021 edition of the Energy Code, anybody know when it was actually heard and put together? 2019. So there's 1819. So there's a lot of new and innovative products and concepts that have hit the marketplace, where the Energy Code, obviously tries to stay very product neutral on it to kind of allow for more things to be in there. But does this type of system meet the criteria that we have listed here? What do you guys think?
I think it meets the intent of the code.
So I have intent. How many of, yes, Derek?
Yes.
Yes? How many of you say yes? Raise your hand. Okay, how many of you say no? Raise your hand. How many of you are not sure? Okay, so here's the great thing. I have locations that I've talked to about this. They're like, absolutely. In fact, it probably works well, because how many of us have ever gone on vacation and said, oh crap, did I turn down the heat, or did I lock the door, whatever the case may be? Anybody do that besides myself? Okay, I'm glad everybody's shaking their head, because I would have felt bad. Yeah, so I think it meets that idea of intent, right? Because I do think it allows a little bit more opportunities of being able to kind of control how much energy usage your mechanical equipment. Now, the flip side of that is, of course, it could get abused or hacked into and all that fun stuff. But with that being said, while the code does not explicitly accept it, it also doesn't explicitly say, no, you can't do it. So the reality is, it's something that you as a jurisdiction would have to make a determination about, am I going to accept this type of a system in lieu of having a physical thermostat. So that's a, hey, I'm going to make you think right now, even though you didn't really want to, because you're like, I'm just going to sit here and listen to her blab about energy as she sucks all of my energy away. All right, well, we're not done with controls for equipment, right? Anybody here hear of the funny or the great concept of heat pumps? A few of you? Yeah, so heat pumps obviously are pretty popular right now. Now, there are some criteria in place on how you're going to deal with heat pumps, because how many of you have projects where heat pumps is the only source of heating for that building? How many of you have it where a lot of them have supplemental heat, just in case that heat pump can't do it? Yeah. So especially up here in the mountains.
When it gets too cold.
When it gets too cold.
Heat pumps don't work correctly.
Yeah, there are some that you have cold climate heat pumps that do perform a little bit better. They are a little bit more expensive, and so they're not necessarily always utilized. So a lot of and what I will say, a lot of times they'll add that supplementary heat. Now, I have a builder that a few years ago, he did a building. All of his buildings had heat pumps, and then the jurisdiction made him also put in supplementary heat, because I think they have like a -13 and wanted to ensure that they had the ability to heat the structure if for some reason the heat pump wasn't going to be able to do it. Totally understandable. He made his design for his buildings where he put all of the insulation, continuous insulation on the exterior of these residential buildings, and used that. He had an R15 on the exterior. And what I will tell you is apparently nobody who has had those buildings that he designed that way has had to use the supplemental heating. The heat pump has been able to do it, but he pays ridiculous amount of attention to the energy code and air leakage that his structures are able to do that really well. So it is possible, but heat pumps, you have to ensure that basically what they want to do is there needs to be a control on it that if the heat pump can handle it, that is the only heating equipment that's activated. The supplemental is not going to kick on. Now, it does talk about the only time it's going to kick on. Don't I have it on here? Nope, I think I hit it. Oh, yeah, there it is. Except, when it's in defrost. I do know that there are some other ones in there that talk about or that have included when there's a malfunction. If the compressor is malfunctioning, then the other one will kick on. That's not exactly what the code says in the 21. In the 24, it just outright says that because it makes a lot of sense, right? We don't want to freeze them out for energy efficiency just because the heat pump is, or the heat pump is malfunctioning. So it does have that. Here's an example of it, and you can't see it very, very well, but right here, it's on heat. And then it also will show emergency heat will kick on, so that will light up for it.
What are people using for emergency heat?
I have seen where they're doing, sometimes they're doing that electric resistance heating. I would say there are more and more people that are getting away from utilizing that. And I'm seeing a little bit more of just actual gas furnaces going in. So that's, well, well, you asked me what people are doing, and in other locations, that's permitted. But like I said, most of the time, when everything is designed properly, that supplemental heat isn't necessarily kicking in. So, all right, this is new in the 21, and this is pertaining to boilers because we have information about, or requirements for all heating stuff, specific stuff for heat pumps. We can't leave boilers out in the cold on this. So basically what this section is talking about is it's going to allow for some of the changes, but you're going to have a monitor that's going to be located outside, so that the idea is while this is going on here, you have a monitor that's outside. So if by chance your air conditioner is on and it gets a little bit cooler and it's cooling things off, the boiler doesn't kick in and start throwing out heat because the temperature cooled down, right? Because it's thinking, well, you know, it's programmed to think, hey, it's too cold, we need to heat the place up. If it's 105 degrees outside, we don't need the heat on, we want to keep the cool on. And so this here lets it know that outside it's 105 degrees, we don't need the heat to kick on. Make sense? It's basically a kind of like how we have set points for, you know, furnaces and so forth, where there's a temperature of 5-degree difference between the two of them so that the heating doesn't kick on at the same time that the cooling kicks on. It's kind of that same concept, but tied to a boiler system. All right. Any questions about controls? Yes?
I guess, can we talk a little bit more about the heat pump controls?
Yeah.
Is there an exception for at what point your heat pump is so inefficient that it would make more sense to switch to a supplemental heat system?
Not in the 21. In the 24, yes. In the 24, they took into a lot of accounts. One of the things is if there's a malfunction in the compressor or with the thermostat, the supplemental will kick in. During defrost, it'll kick in. And then if the heat pump is not able to maintain the temperature inside the structure, then it would kick in. But in the 21, there isn't.
So I'm actually...
Keep in mind that this is a one-size-fits-all code, right? It's trying to encompass everything. I will say a lot of times, especially with the mechanical components, they think about mechanical and they think about those that are at sea level or at more of a sea level than those of us here on the Mile High, where we have to deal with, you know, duration and all of that fun stuff. So I do think that sometimes it could be an option where they submit, you know, an alternative method, means, and material that does say, hey, we want to have a heat pump for most of the time, that because it's, you know, more efficient due to our environment, basically. You know, it just doesn't work as well for us. And so once we hit a certain temperature, we'd like to have it kick on. And it would have to be on an individual basis in that aspect, but the code does not address at what point does which piece of equipment become more efficient. Although I will say I just sat through, for the 2027, a discussion on that a few weeks ago. It didn't make it in because they can't make something that, yeah, because it doesn't quite work across the board type of deal. It's so not even regional, it's almost really site specific. So that was kind of what they were feeling on it.
It's an efficiency of price, so that'll come down to the decision as well. Just because it's more efficient, it might not be cheaper in either direction, I don't mean.
Yeah.
So-
Well, natural gas is a lot cheaper than power too. Yeah,
It-
we're talking about it in that way. And is the power clean? Probably not.
It's getting cleaner. Yeah, it's getting cleaner,
Yeah.
hopefully, you know. So, I mean, there's a lot of things that do come into the conversation with it. Kind of part of this is remember that especially for the 2021, the whole concept of it, and even in the scoping, is the idea was that it's for energy efficiency, right? Energy conservation, not necessarily dealing with, carbon and any of those aspects that have recently been brought into this. So some of those items, I wouldn't say weren't thought of, but they're not something that could be put into the base of the code per what the scoping is and per, how it was, all done with all of that. So, and I can't even remember because as you recall, the 21 had, when it was developed and ready to go, it had appeals submitted to it, and which was part of the reason why it was delayed in its publication. And I don't believe any of those items were in any of the appeals saying it should have been put into the code, if I remember correctly, but there's been a lot of appeals, so don't quote me on it. Yeah, absolutely, absolutely. Remember, this is a class for you all. You let me know what it is you want to talk about and we'll talk about it. But right now we're going to talk about ducks and all the fun stuff that happens with our ducks. It's not chickens, it's not cows, because you all think the energy code is not as much fun, but I'm going to show you how much fun the energy code can actually be. All right. So duct systems have to comply with 403.3.1 all the way to 403.3.7 as applicable. Let's talk about the first one, right? I said we're going to talk about this in a few moments. But basically, if you have ductwork that's located outside of the thermal envelope, you are going to have to insulate those. Now, it's going to be dependent on the size of duct as to how much insulation you actually need to have. So if it's 3 inches or greater, you have to have an R8. If it's less than 3 inches, then you're going to do an R6. Now, you'll notice right here, in the past, all we worried about was our supply and returns, whether they were inside the thermal envelope or outside the thermal envelope. In the 2021, new sections came in to deal with different types of ducts. Ducts that are buried under a building, they're going to have to do the equivalent thermal distribution efficiency. And underground ducts, once again, they have to do that thermal distribution efficiency. Now, that information is not necessarily placed here for you. They have to provide you all the fun stuff, whereas the upper portion is just very straightforward, right? Greater than or 3 or greater, an R8, less than 3, then you're an R6. Now, when we're talking about ducts buried under a building or underground ducts, they are not talking about ductwork inside a crawl space or a basement. Basically, what they're talking about is sometimes when you have like I'm going to say a multifamily complex, right? You have a development, you have this building, you have this building, you have this building, right? And there's a centralized mechanical system for it. So at that point, you might have ductwork that's going underground and under the building and coming up that way. That's what they're referring to when they're talking about these two types of ducts, not what's in a crawl space, not what's in a basement finish, or I'm sorry, a basement.
So when they're buried underneath the building, they won't most likely always need insulation unless they have some sort of below-grade walls that are insulated?
Now, are we, when you talk about buried under a building, are you talking about the scenario I talked about or in a basement?
Not a basement,
Okay.
underneath the slab.
Underneath the slab. Okay.
Question a couple weeks ago, so.
Okay. So what's the scenario so that I have the right scenario in my brain?
Yeah, so I believe, it's been a little bit, but there's this contractor they're called, and he's looking to put ductwork underneath the building. And in doing so, he was asking me if it needed insulation or not. And I told him if it's outside of the conditioned space, it needs insulation, so.
What I would probably do is refer them to this and have them provide you with the documentation.
Okay.
for it because, again, unfortunately, there's nothing written in here that says, hey, it has to be an R3 or an R6 or whatever the case may be, because they do it slightly different, and it's a different type of duct that usually gets installed there. Not to throw out a product out there, but one that's, I would say, probably kind of commonly used is that blue duct. And that does have some thermal resistance to it, yeah. So the burden in this instant kind of falls on them to provide you with that information.
Okay.
That's a great question. Yep.
It says on the shop drawings, like what insulation values it's.
Okay, that's interesting. I've never seen something like that yet, so.
Yeah, the gentleman who got this into the code, he did work for Blue Duct. But that was part of the problem, is like they had something, and because it didn't address it in this type of situation, they were coming up with a lot of issues, and they're like, you know, we kind of exceed that R8 deal, but everybody looked at what they had, and so now we have this fund in the code to help you when you get that one that's going to come in for you.
Right.
Yes.
I actually thought this was pretty cut and dry as far as locating outside the conditioned space. It sounds like you're saying it's like a house that has supply ducts that go under the slab from a crawl space and pop up, you know, on the other side of the slab. Those are outside. That would have to be insulated, correct? You're saying it does not.
If it's outside of the thermal envelope, it would have to be insulated.
Okay.
Yeah. What I'm talking about is in the scenario, you know, if it's going to be like a centralized system that's carrying the heat from, you know, a big cooling tower or whatever the case may be, type of situation going from building to building to building. In my opinion, these two, you aren't going to see it in a single family home. You aren't going to see it in a townhouse. You aren't going to see it in a two-family, and probably very rarely are you going to see it, if at all, in a multifamily project. Where you might get something like that is if you had a multifamily development that was utilizing a central plant to do all their heating and cooling for the...
I've seen it in single-family homes.
You have?
Aspen, no offense to anybody in the Aspen homes, I've seen it and
It's
tested
very
it.
common.
Yeah.
Really? Oh, well... What I'm going to say is send me examples of it. I'd love to see it. I'd love to
And
see
then I've
it.
also seen it outside of soffits too. where
Really?
they're Putting it, yeah.
It's
All
like
right.
if a crossman's too expensive to put in, sometimes they would just do underground ductwork.
Worked on two homes, one in Beaver Creek and one in Vale, that had under slab duct system for heating and cooling.
All right, so these right here pertain to everybody sitting at the tables. I was wrong. I'm okay admitting I was wrong. Hey, you know what? If you don't have the weird ones, then I have nothing to talk about with some of these. Just like sometimes, because, you know, I'm Cherry Hills Village, so I get some unique ones too. We don't have underground ductwork yet, but I have some unique ones, and they're like, nobody does that. And I'm like, wait a minute, let me show you an example on a plan, right? This is what we have. Do what?
They were both built in the early 80s.
Oh, really? Wow. I guess ahead of their time would be my suggestion. All right, so, you know, I like to show pictures and examples. What do you guys think about this? If you were going to, yeah, true to my heart, true to my heart. I'll tell you here, I'm going to tell you a story. I will say that when I went out, I have a city in Texas. They're a smaller city, but they participate in our energy code program out there. So we were doing a training there, and we went out 2 days before the training, because the day before the training, he's like, we'll take you around to all of our construction. You can see our projects, because they went from no energy compliance to they were getting their people, and they were really excited about it. I said, well, let's go. So we get into here, and I'm like, oh, okay. I see it, they had sealed everything up so nicely, except for this one. So I'm taking pictures and I'm like, hey, so-and-so. I almost said the name, not like you guys would know who it is, but I try to be, you know. And I'm like, hey, so-and-so, did you see that? He goes, yeah. He's just like, dang it, you would see that, Hope. But so anyway, long story short, I can guarantee you the very next day it was all sealed up, because as I went down the stairs, I noticed he hung back and was having a conversation with somebody. Anyway, so what do you guys think? Would you be okay if you saw this? Just looking up? Okay, if it was all sealed up, would we be okay with it? It doesn't have to be on there yet. If we're talking about insulation and we look at this, does it meet it?
I don't see the insulation around the boom square.
Okay, I'll give you that, but it is showing that it's an R8 right here. And we know that it has to be an R8 because look at the size that we have going on here. We know this is larger than 3 inches. Okay, let's talk about, this one's going to be a little bit longer here. Okay, so let's go ahead and take like a 10-minute break here. And then we're going to dive into our ducts in conditioned space. That's going to take a few minutes, and we'll get all ready to go. Everybody okay with that? You guys okay with a couple of short breaks?
Sure.
All right. We're going to have some fun talking about ducts in conditioned space. Now, this is going to be important because later on, and I don't know if I put it in this class or not, but remember that the 2021, both on the commercial side and the residential side, but more importantly, the residential side has this new thing that came in that talks about additional efficiency options. And so you have to pick one of the options if you go prescriptive or performance. The only one that doesn't have to do it is the ERI path, but as we talked about, they have to reduce their number compared to what's on the table. So one of the items that you can choose from is having all of your ductwork located inside conditioned space. So we want to know how to get that ductwork inside conditioned space because there's a lot of things with it. But that means, are we only allowing ducts that are truly inside the thermal envelope as those being inside conditioned space? That's my question to you. Because you guys have sat there and you guys got to have a break. Now you got to remember what we're here for.
Can you repeat the question?
Sure. So is having your ducts inside the thermal envelope the only way of demonstrating that your ducts are inside conditioned space?
No, there's options.
There's options.
Yeah.
Okay. Wow, you got it right. You're like, I knew this was a trick question coming from Hope. All right, so let's talk about what our options are. So the first one here is, so that we can consider them to be inside conditioned space, you have to comply with one or all of the following. So the first one that we're going to talk about is, surprise of all surprise, if it's completely inside the thermal envelope, it is considered to be inside conditioned space. Now, that's different than a few things, right? Because we know that ductwork has to be tested unless the ductwork is inside conditioned space or it's inside the thermal envelope, then it's exempt from it, right? That's different than what we have here. This is saying that if all the ductwork is inside the thermal envelope, it's considered to be inside conditioned space. Now, is this ductwork inside conditioned space or outside of the thermal envelope?
Yeah.
Does that look,
Foam wall,
Ceiling.
that's a ceiling, that's
Okay.
foam.
Okay. I thought that was a wall.
Oh, yeah, I thought.
This is a wall. This is the ceiling.
But it's insulated everywhere.
How many of you say it's inside the thermal envelope? Raise your hand. How many of you say it's not inside the thermal envelope? Raise your hand. How many of you are not sure and heard a comment earlier about Hope being tricking and think that I want to raise my hand? Okay. Well, it is inside conditioned space. Here's what throws people off a lot. What did they do with their ductwork?
Insulated.
They insulated it. Do you have to insulate it if it's inside the thermal envelope?
Oh, but you can.
But you can, exactly. Typically, whenever I ask that, everybody sees this and they say, oh, it's outside the thermal envelope because they insulated the ductwork. You can't make that as the determining factor. You have to figure out where their thermal envelope is by the insulation as to whether or not it's inside or outside of the thermal envelope. What do you guys think about this one?
Depends where the insulation is.
Depends on where the insulation is. If you were to hazard a guess, you walked in and you saw this, other than that's a really horrible job with some of that ductwork installation. Oh, you should wait to see some of the pictures I have to show y'all. Y'all are going to be like, that didn't come from my jurisdiction, right?
I want it on the roof deck, so I'm going to call it inside conditioned space.
Well, this one is actually outside of the thermal envelope. It was going to be at the ceiling level. But, you know, just to throw you off, I probably threw you off with the whole insulating the duct deal, and you're like, you aren't going to get me twice. All right, so number 2 in that list. Number 1 was if it's inside the thermal envelope. Number 2 is if you happen to bury the insulation inside the ceiling, complying with R403.3.3, and you also have to comply with 2.1 through 2.2. Now, we're going to go take a look at what 403.3.3 actually tells us. So when your supply and your return ductwork is completely or, and this is the incredibly important part, I want you all to remember this, or is partially buried inside the ceiling insulation, it's got to comply with all of this to be considered as part of conditioned space. So, you have to insulate your ductwork, supply, return to at least an R8. You also have to have below the ductwork at least a minimum of an R19 insulation below it, and then have the remaining insulation for that ceiling insulation surrounding it. And basically you also have to have that, so for us, we're going to have like an R19 above it. Now, what it also is telling us that that R8 insulation that is, around the ductwork does not count towards that R19. So you're basically doing R19 plus that R8. Now, number 3 doesn't really count because we don't live in any of those climate zones. So this is what they are asking for. Here's our ductwork. Here is our gyp board. From here to here, we have to have at least an R19 below the ductwork right here. That does not mean this duct rests on top of the gyp board and everything surrounds it. It has to have at least an R19 below it. And I've had people say, well, how are they going to do that? You're going to do some strapping. That's all there is to it, right? The other thing is, obviously, you have to have an R8 all the way around that insulation or the ductwork, and then have the remaining insulation all around it, including an R19 above it. So basically you have, yes.
I just have a question, I'm sorry.
Oh, no. Ask your question.
Because side note, I think this is important because it dictates the threshold for the duct leakage testing. Because if you're.
We will get to that.
Yeah, so I find this really important. Why would you want more insulation below it between you and the thermal envelope? Why wouldn't you want it down as low as you possibly can so you can get more insulation from, from the exterior, from the outside world?
And that is a really good question. When this came into the code, I think it was the 2018 edition that it came in. The people who brought it forward had a lot of building science behind it. And so when they were doing all of their calculations and all of the stuff for it, to demonstrate that it basically functioned the same as if it was inside conditioned space, was to have the R19 below it.
Okay.
Yes.
My question is, I mean, if the duct is outside of the thermal envelope, then you just need R8.
Correct.
Why would anybody jump through the hoops to do this?
Because if we go into R408, having your ductwork inside the thermal envelope isn't a bad way to go, and you might have a portion of your ductwork that you would have to comply with this to meet that other option in there.
That's efficiency, the additional efficiency packages.
Correct. In the 21, it was basically introduced in all of this. It may not seem that pertinent maybe now, but I will tell you in the 2024, you're going to be so incredibly grateful that you have this, because it really does help with what's coming down the pike. All right. Now, we're jumping all the way back to 403.3.2, and these are the additional criteria that you have to do. You have to make sure that that air handler is inside the thermal envelope, so it couldn't be up in the attic, right? So the idea is you have a conditioned crawl space, it's going to be in the conditioned crawl space, but you know that you're going to be putting ductwork up in the attic, and the ductwork can follow all of this, but your air handler has got to be inside the thermal envelope. The next one that you were alluding to is the fact that you have to demonstrate that it does not leak more than 1.5 CFM per 100 square feet of conditioned floor area. Why that's important is because just if you were testing it and not following this, depending on if you have an air handler or your air handler in or not installed, you either have to demonstrate your duct do not leak more than 4 CFM per square foot, 100 square feet, or 3. So that does put, you have to make sure that your ductwork is really tight.
That's duct leakage to the outside, not total duct leakage.
No, I believe it's total duct leakage.
Okay.
I'll have to look that up, but I'm pretty sure. It's whichever one, because duct leakage to the outside is the one that is utilized for the simulated building performance.
You can do either.
All right, there we go. And then number 3 in that whole scheme is basically kind of for all of us that are out there doing inspections. When we go out to do the inspections and the insulation has been installed in that ceiling, we better not see that the entire ceiling is a level amount of insulation. We better see bumps all over the place from where the ductwork is, because the reality is, it's not like water where it disperses everything, right? It takes up space, so we better see that it's taking up space in that attic. How many of you go into an attic and this is what you see? So you should be seeing something like this. All right. So here's my question for you. This is a real live example of this concept? How many of you look at this and say, oh, I would accept this? How many of you look at this and say, oh, I would not accept this? How many of you are not sure and is hope will give you the answer to that? Oh, there we go. We got hands. All right. So here's a story. There's a location that I go out, and every year I go and do an energy training for them. All their contractors come in, and we do a couple of days of training. Went over this concept for them because they were on a much older energy code, so this was new, and they're like, oh, this is great. All the builders loved it. Problem was, what they were finding is they were failing their inspections. So the deputy building official reached out to me and was trying to explain to me what was going on. And I said, well, your inspectors are right. You do have to have an R8. You got to have an R19 below, you know, the ductwork. And so we kept going back and forth a couple of times. I'm like, no, that is correct. And he goes, I'm going to send you a picture. And I said, okay. And he goes, I think you'll understand it, what I'm trying to say. And I said, okay. This is where, remember I said sometimes you can read something, interpret it one way because you have all of your life experiences. The person next to you reads the exact same section and they interpret it a different way because of all of their life experiences. Well, I got the picture and I'm like, oh, okay. And he said, well, the inspectors are failing it because where the ductwork comes through the ceiling, it doesn't have an R19 below it. How many of you are like, oh, well, that makes sense. I would fail it too. How many of you say, no, I would pass it? How many of you are like, I'm still waiting to see what Hope said? Well, I reversed myself and I said, oh, okay, I see what you're saying now. I said, your inspectors have it right. It absolutely has to have an R19 below it, but if we don't have the option of getting the ductwork up into that attic, there's never going to be an opportunity for an R19 to be below this ductwork, but they have it everywhere else. And I said, plus, if you come here, it says is partially or completely buried in the ceiling insulation. So even the code section is understanding that you're going to have a point of where the ductwork is coming through that thermal envelope barrier to get outside of the conditioned space. So now that I explained this, how many of you now say that this works? All right. How many of you still say this doesn't work? All right, Derek, what do you say?
Where's his R value above that ductwork?
This here?
Above it? Yep. No, where that transition is, where it drops through the ceiling.
Right here?
Yeah.
Okay, so that one, remember that when the energy code is looking at this, it's unless you are utilizing that option in 402.2.1 where it says, hey, you must have at least an R38 up and over the top plate, the energy code takes into account that you're compressing it at the top plate. So it is another area that you probably are going to be maybe a little bit concerned, but the sheer fact that they are meeting that wonderful word called intent. They were insulating to an R8. They were making sure they had an R19 below it. They had everything above it, and they even had the humps going on. I forgot they had a song that they were singing with it at one of my last trainings. I'm like, all right, whatever. They were having fun with the energy code. See, I am not the only one that has fun with the energy code.
What happens if that ductwork gets too close to that roof duct with no R value there? Is it will melt and create icing?
It can create an issue, absolutely. But I will say that I am sure that it had some insulation there. I will tell you, remember that this came from a deputy building official. And he may not have had the best drawing skills. You guys have seen my drawing skills. This is excellent compared to my drawing skills. All right, here's our third option. Because we may not have everything inside the thermal envelope, we also may not have everything inside the attic because we have these things called garages. So often we have ductwork that's going to be in a floor cavity. So in this instance, if you have insulation in a floor cavity that you're trying to say is inside conditioned space, you're going to have an air barrier that separates that ductwork from the unconditioned space, which in all reality, all the floors have to have anyway out of 402.2 or 402.4.1.1, right? So that's not all that crazy. Second one is you have to have your floors insulated to whatever the table tells you you have to have it insulated to. Is it an R30? Is it an R38, right? Well, but anybody in climate zone 7? Okay. Well, 30, 38 if you're in climate zone 7. And then you have to have a minimum of an R19 insulation that separates the ductwork from the unconditioned space. So this is what they want. Here's our lovely floor. So we have an R19 from here to here, separating it. We have an air barrier that's also separating the ductwork from the unconditioned space. And like I said, we have an R19 there. I've seen this done forever and a day in projects, in garages, I would say for almost 2 decades now before it ever made it into the code.
Yeah, we do it for plumbing too.
Plumbing, yep. Now, the energy code residentially doesn't necessarily address that, but same concept for it. All right, so here's classroom participation, because you guys have sat there. Looking here, if they wanted to say this ductwork was located inside conditioned space for this floor, will an R19 fit below the ductwork and the bottom of the joist there? I'll even blow it up for you so you have a little bit better. How many of you say yes? I think they can get an R19 below that ductwork. How many of you say no, I don't think they can get an R19 below that ductwork? How many of you are not sure? Okay, I'm going to say most of you are correct. And you say, how can we all be correct? Well, how many of you thought of batt insulation or blown-in insulation when I asked you that question? Okay, so we know that that has about between a 3.2 and a 3.8 R value per inch. So that means what? 5.5, 6 inches is what we would need there. Now, if we looked, we probably don't have 5.5 inches below that ductwork, right? But what if they were using closed cell spray foam? Closed cell spray foam can get all the way up to, actually I've seen recently an R7 per inch. If it was closed cell spray foam, there's a very distinct possibility they could do it. Now, how many of you were here for a residential thermal envelope class? Only 1, 2? I'm like, a lot of you were here. I know you guys were. Think back. Remember, there are new options now about how you design your thermal envelope for your floors. So remember, you could have insulation resting on the gyp board, or you could have insulation resting on continuous insulation. So you could have your batt insulation or your blown-in insulation resting on top of an inch of rigid insulation, and you might get there. So that's why I say there's a possibility that all of you are correct. How many of you are like, ooh, I'm not going to fall into that trap again? I'm not thinking blown in or batt insulation. What do you guys think about this one? Do you think you can get an R19 below that ductwork? So here's the bottom of the ductwork. Here is the bottom of the joist. You can see kind of the distance going on here. All kinds of room. I agree. I think even if you were looking at maybe the worst blown in insulation, some fiberglass blown in that's a 2.4, 2.8? Well, maybe not, but you can get quite a bit underneath there, and I think you could very easily get an R19. What do you guys think about this one? Think it would work? It would be incredibly tight. And this is where it becomes, if this is on the plans and they're listing this, this is where, as plans examiners, that we want to make sure that we have the information there, because a lot of times we do not get mechanical plans, outright mechanical plans, right? Sometimes we get a manual JS&D. Manual D will show some stuff on there, but it doesn't necessarily show that we have enough depth in there. So if that's something that they're going to do, this is where having those conversations with the super, having the conversations with the mechanical guy and say, hey, I see this option was chosen as your, additional efficiency requirement. Make sure you have enough space to meet that R19 below it. And they'll say, what are you talking about? And you'll say, oh, well, let me help you out. I got a great slide to show that. All right, so this is only in the 21. So don't get used to it, but it is an option for now. So in this one, it says if you have ductwork that happens to be within exterior walls, this is how you are able to make them be inside conditioned space. So the first thing is you have to have an air barrier that separates the ductwork from wherever that unconditioned space is. The next thing is you have to have an R10 insulation that is behind the ductwork, and it's basically separating the ductwork from the outside. And then the third thing is the rest of the insulation just has to be fully around it. So where we would have to have an R30 cavity wall, I'm just throwing that out there, 10 of it would have to be behind the ductwork, and then obviously everywhere else you can have the R30. You aren't going to get an R20 in front of that ductwork, but you are going to fill that ductwork where that ductwork is. All right, now, this is the effective R value for deeply buried ducts. Now you'll say, hey, Hope, didn't we just discuss this? And I'm going to say, yes, we did, but we did it for those that are utilizing the prescriptive compliance path. If they decided that they were going to go with the total building performance option of the compliance paths, and they wanted to show that their ductwork was inside conditioned space, this is the section that they would have to utilize. So they have to comply with that R403.3.3. That's the one that talks about insulating the duct to an R8, R19 below it, the rest of it all around it. It also talks about when you have your ductwork and you have blown-in insulation all around it, it has to be a minimum of an R30. You are not permitted to trade it down in the performance path below that R30. And you are required to have at least 3.5 inches of insulation below the ductwork and above the ductwork. So it doesn't matter, there's not an R value there, it's inches that's being quantified in this particular one. Now, again, this is only if you're going with the total building performance option, and it's basically one trying to ensure that if you are trying to claim that your ductwork is in inside conditioned space, when we're talking about in an attic, that it meets everything here. And then 2, it also has criteria for how far you can kind of trade away your insulation values so that you aren't going below in what's listed within this section. Obviously dependent on which climate zone you're in. All right, so question for you. You'll notice that there's been a lot of talk about duct sizes and, ensuring that we know where the ductwork is getting located. Where do we find this information? I hear mutters, just be loud and proud.
I said by plans.
By plans, all right. What if they weren't on the plans? What other location or item might we find that information? Manual D, there we go. Yeah, a Manual D will give us at least information about where the ductwork is going to be located so we have a better idea, right? Because unless it happens to be a multifamily project where they actually provide us with ductwork plans, right? Like mechanical actual plans. Usually our only mechanical plans that we get is that Manual D. So here is a lovely Manual D, and it's a lot of fun to read, right? Now, if we took a look at this room up here, it gives us a little bit more information here. I know that this is a 6-inch duct, and I know that this is a 5-inch duct. Now I know this is a 6-inch because over here it says 6 inches, and it's 17 feet long, and it just has a line, but to me it's kind of like pointing to where it is. And then this one here that's pointing to this ductwork is 5 inches, and it's 12 feet in length. So does this help us with any of the information that we just talked about? We know that if it was outside of the thermal envelope, we know how much insulation is required, right? So if it was outside the thermal envelope, how much insulation do they have to have? All right, yeah. Now here's another example. I think this one is Right Soft. This one is an Elite, I want to say. So it doesn't quite give us as much information, but I do know that this is 5 inches. We got 5 inches here. This is just the trunk line. Well, it doesn't have all that information, but here's another example of a Manual D we might get. All right, now here's the really fun one that I love. This section of the code, believe it or not, is incredibly, or at least in the past, debated about. And it's the sealing of the ductworks and all of that fun stuff. And you're like, Hope, why is that contested? It's not necessarily the idea of sealing it is contested. It's some of the other things that come after it that pertains to this particular section. Now, how many of you see notes on your plans that talks about sealing up ductwork? A few of you, yeah. That's one that I am perfectly okay with them providing a note. I don't want it buried in the general notes because how many of you read the general notes? Okay, how many of you, when you're not being a plans examiner, read the general notes? All right, so a couple of people, but the reality is what I'm going to want is I want to see a note somewhere outside of the general boilerplate notes because half the time those notes are incorrect anyway. So I want a note that says, hey, seal up ductwork. You know, we can say per the section and the IMC. Some people say per the IMC, that's, or the mechanical code. And I would be okay with that too because this section also refers to, you know, sealing it how it needs to be sealed. SMACNA, that's another one. As long as it has something very visible on a non-hidden page, although I'm seeing more and more energy sheets being provided. How many of you are getting energy sheets? And on those energy sheets, I will see a note that says something like, you know, everything getting sealed up per this section in SPACNA or what have you. And I'm okay with that. I'm not okay with this. Anybody have a problem with this besides myself? Everybody okay with this? So this is illustrating, you know, what happens when we don't seal up our ductwork. Of course, yes, this is a commercial project, but air doesn't, you know, act differently if it's going to be a commercial project or a residential project. You're going to have this stuff floating around all over the place, right? Now, here is something that, you know, you'll think about is, anybody want to guess where this is at?
A restaurant.
Oh yes, it is at a restaurant. You've seen this slide. It was at a restaurant right over where they were cooking my food, and I was sitting here just staring at it thinking about all the extra seasoning I was getting on my very expensive steak. Yes. What was that?
It's cooked off.
It's cooked off. Oh, yeah. Well, you know, I guess they have those finishing seasonings for it. And my husband and I got sick one time, and that's all I could think about was I know where it came from. All right. Now, here is something that is incredibly important to realize. So we have testing criteria. You are required to test your ductwork. You can have options. You can do it at rough-in. You can do it at post-construction. The choice is all yours. The only thing is we do have to have a report provided to the code official that says that I do not exceed the numbers that we're going to talk about here very shortly. Now, there is an exception. The exception is dealing with ductwork that is being utilized as part of the ventilation system, as long as they're not part of heating and cooling, right? So this is where it's incredibly important to know, are they doing exhaust only? Are they doing supply only? Or are they doing a combination, right? Well, for all of you up here, you guys all have to have ERVs and HRVs, so they're doing a combination. So those ERVs and HRVs, as long as they're not part of and integral to your heating and cooling system, that ductwork should never be tested, right? That system there is there for ventilation. It has nothing to do with heating and cooling, even though technically heating and cooling is going on in that ERV, HRV type of deal, right? Okay, so here's what we have to do. So at rough-in, if your air handler is installed, you have to demonstrate that you do not exceed 4.0 CFM per 100 square feet of conditioned floor area. If your air handler is not installed and you are doing it at rough-in, then you cannot exceed 3.0 CFM of 100 square feet of conditioned floor area. If you're going to do it at post-construction, you cannot exceed 4 CFM for 100 square feet of conditioned floor area. Now, here's the fun one. If you have ductwork that's located inside the thermal envelope, in the past it was exempt from being tested. You didn't have to do the duct leakage test. Now you are required to do the duct leakage test. You just get the ability that it gets to leak an awful lot. You get to go all the way up to 8.0 CFM per 100 square feet of conditioned floor area. So the idea was for this is, they said, if it's inside conditioned space, we don't really care if it leaks. And a lot of us then said, well, we do care because then we're not getting the CFMs at the destination and our systems don't run properly, and then we have less energy efficiency. But oh well, it is what it is. So you are testing now. Now, how many of you have ever seen a duct leakage test performed? How many of you would like to see a duct leakage test performed? We can throw on a video if you guys want to and take a look at it. Maybe. We are going to give it a shot then. Typically, if they are testing at the final stage, the ductwork is going to be leakier. And so it's not uncommon that you'll have more leaky ducts at a final stage as opposed to doing it at rough-in. Just because there's more things that happen, right? You have everything pristine. If you have something installed in a building during construction, does it never get knocked or, you know, have something hit it and so it dents the ductwork? Because it always stays pristine, right? So that's kind of what he was referring to there. Thanks for sticking around for the attempt of the video. I really did try to bring you some fun and excitement here. All right.
Oh,
Yes.
and I've done a lot of duct leakage testing. If you haven't done it and you're designing systems that are quite complicated, i.e. lots of ductwork, be afraid of the test. It's there. I do blower doors as well. We do tons of blower doors. I'm not as concerned with blower doors. I'm much more concerned with duct leakage. They are failing. The guys who have done this for years are failing. So you just, not only is it how good, how much pookie, you know, how much mastic do they get on there, but it's like if there's 400,000 feet of run, it's just, you know, death by 1,000 cuts. There's not just one little, you know, one giant hole is great if you can find it, but I wish it was easy as blower doors. That's all I'm saying. They're as we make our duct systems more complicated, they're getting and they're being tested now. Be afraid. So.
And I would yeah, no, I would say too, I mean, if you think about it, you got your ductwork in, everything's all sealed up and everything, and then somebody comes in and they're going to put the drywall. What happens? It bumps it. Do you think that sealant stays all the way around? No, it's the cut of 1,000, or the death by 1,000 cuts. So there are.
So is it almost better to spray that sealant in there before?
I mean, if a bunny was an issue, AeroSeal everything.
Oh, AeroSeal, yeah.
Yeah, that's.
I'm not promoting AeroSeal, but there are a lot of locations. I do know of a location, I'm not going to say where, but they do require that all their ductworks have AeroSeal to it.
For a while, there was only one company in town that did.
Yeah.
This is outside of Colorado, though.
Well, this
So.
is in this valley.
Mm-hmm.
Also, oxygen systems, if you have like a whole room oxygen system, things
Those are becoming very popular up here.
Oh, really?
not
Oh,
just
yeah.
the ductwork.
Hmm.
That throws a whole nother.
Layer of complexity.
It cannot be installed in PEX.
And what was that?
Oxygen
Oh,
cannot be distributed with PEX. I've seen that. It's highly toxic. You see that?
it's fine, Derek. What's a little toxin amongst friends, right? Well, speaking of toxins and what you can't do, you cannot utilize building framing cavities as ducts or plenums. Because guess what? Do you think you can pass a duct leakage test with it? Probably not. I don't know if you've ever seen, drywall. Do what?
That's how it was done for a long time.
Oh, it was forever and a day. And in fact, this is one of those areas that you have a conflict between codes because the energy code says absolutely not. What does the building code say and the mechanical code say? Doesn't say for everything, but there are certain instances when we start talking about fire-rated construction and so forth that does allow for their use. Yes?
Well, plenums, return air plenums cannot be combustible, so that throws that right out if it's wood frame.
It does, but it doesn't say wood framing cavities, it's building cavities. So even if it was steel, even whatever the case may be, right? And gypboard is, considered non-construction. Yeah, no, I don't disagree with you, but I will tell you that let's just say I had a very interesting conversation at the mic with somebody because I was told to stay in my lane and don't go over to the building side of the code hearings because my place is at the energy code. I'm like, I was doing building codes long before energy codes sitting at the hearings and everything. So when this came up and it was supposed to be removed and everything, he went to town, and then afterwards he's like, stay in your lane. And I'm like, you know what, buddy? All of these are my lanes, okay? I'm not because he's an advocate and a fire advocate. And so it's like, you know, I don't get paid to come here. In fact, I usually end up using vacation time to come here. I have every right to be on any mic I want to. All right. Oh, here's a fun one. So let's talk about mechanical piping systems. They are required to be insulated when you have anything above 105 or anything below 55 of fluid temperature that's running through it. You have to insulate it to a minimum of an R3. This is where I'm going to say, let's have a conversation. And I'm sure I hope that nobody has had this same experience as me, but we have piping, right? And we have insulation going to right there. Should we have insulation surrounding the tubing in in-floor heating? No, but technically, what does the energy code say? Is that piping holding fluids that's 105? But what do we have? We have common sense. Oh, well, let me rephrase that. I shouldn't say that. So I unfortunately went out to do an inspection. Never in a million years did I ever think that this was an issue, right? I never, ever, ever, ever want to have a conversation again where I say, I am so sorry, you cannot insulate the tubing in your floor heating and you have to remove it, because they did do a really good job with it. That is not a conversation I ever want to have again. And it's really hard because they say, but the energy code says I have to. He's not wrong, or I mean, like, he was not wrong.
But how's it going to heat?
Exactly, and so,
First year mechanical?
I was talking to the super for the house. And this was not his first house. It was not he'd kind of been around. I've seen him before, but that is not, just understand, right? And I've been doing the energy code for a long time before this happened. I never, ever, ever thought that I would have to say, hey, as a caveat, don't insulate inside the floor. Because I just thought we all had common sense that the idea was we want that heat to come up, right? And heat it, all that fun stuff, and yeah.
It's not wrong to put that poly there or the butylene insulation where it comes out of the slab.
Yes.
Right here?
Yeah, because that Wurzbow or that PEX is gonna get moved around, and it gives you some room to move it without, breaking it or cracking it. So
Yeah.
it's actually a good place where you want it. Same with like a plumbing vent, we put usually a sill sealer around it as it comes through the slab. Same thing, so it can move, have a little flexibility.
A little flexible and be a little bit protected.
That's the only way.
This is okay,
Yeah,
not inside the flooring.
right.
Yeah, that makes sense anyways, because that way you don't create a hot spot right around that edge.
Well, in this particular instance, I will say, everybody says, did you take a picture of the floor? And I wish I had, but I felt so bad. That was not my main focus of the conversation. My main focus of the conversation is, this was not a small house. This was like 9,000 square foot house. So imagine how much work went into that.
Material.
And take it
And material, yeah, oh my gosh, yeah. Here's the really good thing is I didn't have to go back out for the re-inspect. Somebody else had to go out and do the re-inspect for it, but that was a tough like I've done a lot of really tough inspections. That was the most difficult, one of the most difficult inspections that I had to say you fail on, because they really were trying and they really did read the code. The code really does say that, right? Oh, anyway, okay, sorry. That's one of my things. So, if you have piping insulation and it happens to be exposed to the weather, we have to ensure, right, that it's protected from sunlight, moisture, wind, right? Kind of the typical things that we have to pay attention to. But whatever we use has to be shielded from solar radiation, and it has to be removable. You cannot use adhesive tape as your insulation covering for your piping. And in later codes, it'll actually say and paint, because paint is getting, I guess, used for it. All right, let's talk about our heated water circulation, temperature, and maintenance systems, right? So this, you guys probably have a lot of this going on in your areas, right? So there is some criteria with it, depending on kind of what you're trying to do. If it's a heated water circulation system, we're going to take a look at 403.5.1.1. We're also going to talk about heat trace. Anybody using heat trace up here? Yeah, I'm sure I've seen a lot of your guys' plans. I know you guys use heat trace up here. It gets cold. And so there are some control requirements. The big one is manual controls have to be ready access location. What that means, it is not talking about accessibility. What it's talking about is that you have to have it where it's in a location that you have access to, meaning the controls could not be up there at the ceiling location for us to be able to control or maneuver or whatever the case may be. It could be up here on that wall. So that's what they're talking about when they talk about ready access. So let's talk about circulation systems. So you have to have a pump when we have these systems. You cannot have gravity or thermal siphon circulation. You have to have controls. Those controls are going to turn off the pump when it happens to be at the set temperature and there is no demand for it. Now, return pipes can be dedicated or cold water supply. Now, here's the fun one. Controls, oops, I don't know why I was pointing at it on my laptop. Controls cannot exceed 104 degrees. So basically, you can't have your water set at 120. It's going to make sure that it's only the demand temperature is at a maximum 104. Now, if you have demand recirculation water systems, the control that they want to have is basically that it's activated when a user is sensed, or that there is a need for a flow of hot water to go to that fixture or the appliance, and that's what it needs to have. So there's very little when it comes to demand circulation compared to just circulation systems. Now let's talk about heat trace systems. So heat trace systems, and remember 403.5 is dealing with some of the plumbing criteria, right? Or some of the mechanical heating on that. And what it talks about is you are going to ensure that that heat trace system complies with the standard IECC 515.1 or UL 515. And then the controls. The controls are going to be there that maintains the temperature in the pipe, and it's in accordance with times of the day and the heated water use per the occupancy. So in this deal, if it was something that, hey, nobody's here until the weekend, then that's when everything is, we're going to make sure things are working with it. So basically, there is a little bit of foresight that's going to come into this. Now, if you'll notice, it goes through a lot of things, not so many things, and probably even less things to worry about. Now, the next one is, whatever that piping is, this is the insulation section that requires that hot water piping is going to be insulated. Now, it only has to be insulated to an R3 and only in the items that are listed in here. So if it's 3/4 of an inch or greater, it's going to need to be insulated. If that piping is serving more than one dwelling unit, if it happens to be located outside of conditioned space, which is what that one is, if the water heater or from the water heater to the distribution manifold, if it happens to be under a floor slab, that's the one that I get a lot of questions about. If it's buried, and the new one for the 21 is the supply and return in circulating systems and recirculating systems have to be insulated unless it is the cold water pipe return for that demand recirculation system. Aren't you glad I said systems 3 times in that one sentence? So here's one of my favorite ones. So we see this image here. And I have a lot of inspectors that say, how do I know that under the slab it's completely insulated, or all of it that's outside of the conditioned space happens to be insulated? How do I know what's happening below there? And I tell them to look around, because a lot of times, very rarely do we have a single home being developed, or very rarely do you not see, when you're out there doing other inspections or driving by, that you can tell that they've been insulating in all the other areas. If they've insulated all the other areas and all you get to see is this, chances are they've done it, because why are they going to go through and only insulate a small part of it? All right, this is the one that I really am excited about, and I wish it got utilized a lot more, but I do understand why it's not getting utilized as much, because I do understand the cost behind it. But you know how ERV and HRVs work, where you're preheating or pre-cooling, I guess, the air as it's coming into the structure for the ventilation, right? So this is kind of doing that same concept with the water that is going to get heated. So prior to the water going into whatever is going to heat the water, you have the opportunity that you can take the heat from your shower. You can make that hot water shower work for you. And so what it does is it preheats the water before it goes into the whatever is going to heat your water, because it takes all the heat from the waste drain and preconditions the...
You're going to have these all over the house? I don't get how that would work.
Well, and I might have a picture of it. I didn't put the pictures in it. So basically you have the drain from the shower. You've got copper piping wrapping all the way around it, and then it leads into the whatever is going to heat the water heater, right?
What if that's 400 feet away?
That's why it can get expensive. But what it does do is it does take the heat from that water that's literally going down the drain and uses it to preheat the water for it. I see a lot of them, like, they may not be in all of the showers, but there are a lot of showers that are right next to where the heating element happens to be, and so they'll get utilized. Because remember, this is capturing the second law of thermodynamics, where the heat will always go to the cold. So your hot water from the shower that's going down the drain is warming up all the cold water before it actually goes into the heating.
But are you paying electricity to pump that?
No,
It's gravity.
it's all gravity. Yep. All right, mechanical ventilation. This is where I just want to remind you that this is not a requirement out of the IECC. The requirement to have mechanical ventilation comes from the IRC, the mechanical section, or the IMC in all of this. Now, what the Energy Code does have is some criteria that addresses mechanical ventilation, right? So I'm going to go through this section quickly because you don't, in the IRC, you have the option of going with exhaust only, right? That would be like a bathroom exhaust fan. Or you could do supply only, where you pipe in fresh air from outside into the system before it goes into the handler. Or this is the one that you all are required to do, and this is balanced ventilation. This is where you're going to use those ERVs and HRVs, kind of dependent on where we are on things. And that's what is all that I just showed you comes out of the IRC and not out of the Energy Code. There are some things that you have to ensure, like the efficiency, which we'll talk about here shortly. But I just wanted to kind of bring that to everybody's attention. Those are the options that are in the mechanical sections, but we're talking energy. So remember, anytime you have an inlet or an exhaust outlet, it is required to have a damper. It has to have the damper close when we have ventilation not operating. Now, here, if you are in climate zone 7, how many of you are in climate zone 7? Okay. Climate zone 7, you are required to have an ERV or HRV in this edition of the code. So that is required to be utilized as your whole house mechanical ventilation. For some reason, I was thinking we were all climate zone 7. We have some climate zone 6.
We're 6B.
Okay, so
7.
okay, so 6B still has the option of supply, exhaust, or balanced. In climate zone 7, you only have the option of the balanced system.
And in 2024, it goes.
It includes 6, 7, and 8, and just wait till what the 27 comes. So,
It's less strict?
yeah, if you're standing on your head. No, so in climate zone 7, you are required to have an ERV or an HRV. Now, the thing that is important is it's not just having an ERV or an HRV. You also have to ensure that your sensible recovery efficiency is at least 65% at 32 degrees. And you usually see that it'll have information here maybe, and I don't think I put it on here. Oh, I probably did here in just a moment. So just an FYI to put this in here, because some people ask me what's the difference between an HRV and an ERV. And the idea is basically an HRV is something that we would have here in Colorado because we don't have a latent load. An ERV addresses both sensible and latent load because we don't have any moisture. Most of the time we don't really have any moisture. If we were in Minnesota or Chicago or down south, way south Texas where they have humidity, Louisiana, that's where you're going to be looking at an ERV. But for us, what we're looking at is an HRV. So here's where we're looking for. We wanted to show that it has an SRE, a sensible recovery efficiency, of at least 65 at 32 degrees. So does this meet that criteria? Yeah, because it's showing that it has an SRE of 83% at 32 degrees. So this system would work with the criteria if it was going into climate zone 7.
By the way, that system has to be installed in a conditioned space. You can't stick in your attic. Hope for the best, as I've seen.
It always has to be installed per how the manufacturer requires for it to be installed, and most of them do say, or at least, I shouldn't say most of them, the ones I've seen do talk about being in conditioned space. I see them a lot when they're going in, they put them in closets. So this is the other part where the energy code comes in. So basically, our whole house mechanical ventilation system is a requirement out of the mechanical code or the IRC mechanical section. The energy code says, one, we want to make sure that that fan meets the efficiency that we find in table R403.6.2. It happens to meet the criteria, but what we now have is this here, that the fan efficiency for the whole house mechanical ventilation fully ducted shall be determined using the static pressure of 0.2. And then it also talks about other ventilation that comes out of the IRC and the IMC that the energy code is regulating. And all it's regulating here is just the efficiency of the fan. So the criteria of the ventilation comes from mechanical IRC, but the fan efficiency is here. So here is the table. What I will tell you, this table hasn't really changed in a couple of cycles here. So what I will say is mechanical manufacturers for a long time have been producing fans that meet these efficiencies. So it's not necessarily like it's a tough one to do here. It's almost one that if I had to look at 1,000 other things and I had to kind of remove one from my list for the day, I would feel very confident knowing that I've seen all the equipment out there, that if it's installed correctly, it's meeting all of these efficiencies. Now, here is the next one. I have the test to show you how the testing works, but unfortunately we can't get the video audio to work, so I'm not going to show you the video, I'm just going to talk about it. So, in the 21, there is a requirement that all mechanical ventilation systems have to be tested and meet whatever criteria it is that is listed basically out of the IMC and the IRC, because that's where those ventilation rates actually come from. And so this is saying we need to demonstrate that it is meeting that criteria, and then we get a result provided to the code official that says, hey, we tested it all works. The only thing that is exempted is if there's a kitchen range hood and it's ducted to the outside and it's at least 6 inches, but only if it doesn't have more than 190-degree elbow. If it does have more than one, then it's going to have ventilation testing. So, with that being said, anybody want to know a nice little tidbit about this? How many of you are wondering, how did this get into the energy code? Anybody?
Jason needed a job.
Well, here's where what the person who submitted it said. Because I was not against the thing, I was against that it was in the wrong code. This should be in the IRC, not in the energy code. And the first reply was, well, it'll be easier for me to get it into the energy code than if I tried to put it in the IRC. And I'm like, see, now that's one of the first things that is like, you just hit my bad list with that comment. But 2, he said, now this one I will say does make sense. He goes, the people who are going to perform the tests do the duct leakage testing and the blower door tests, and those are tests that come out of the energy code and not the mechanical code or in the IRC. And I'm like, I understand that reasoning, and if you had led off with that, I would have been like, okay, well, let's also like reference or put it into the residential code and go that way and then remove it. But you tell me it's easier to get into the energy code. That just doesn't set you off on a good foot with me on that. So that's how it happened. That's really what it's referring to. That's why the last few slides I've been very, or trying to make sure that you understand that a lot of these things that has to be tested here come out of the IRC, and they're not provisions out of the Energy Code. But this section brings it to the Energy Code. All right, so if you were to look at this exhaust fan and look at it go up, how many of you think that how this was installed, it will actually get the CFM that is required by code and listed within the plans? How many of you say yes?
Depends on where you insulate it.
How many of you say no? How many of you are not sure? Okay, what I would say is it's pretty straightforward. There's no crushing of the ductwork. It was a decent install, so we're probably going to get it when it's tested. What do you guys think about this one?
There's kinks.
Do you guys need a little bit of help on how it goes? So it starts here, goes up and over here, comes around, and comes around out here to go all the way out the building. How many of you think it's going to meet the ventilation when it's tested? What? Okay, how many of you don't think it's going to meet the ventilation? Here's another one of those, because I took a new employee out with me when I did these ride around, I guess you could say, with this jurisdiction. And in all fairness, this project, everybody was fired off the project because the super, it was a multifamily project, the super came in and said, I don't like that electrical panel being right at the front entrance, and decided that it needed to be at the fire separation walls separating each unit and cut into it. Not only the electrical panel, the plumbing, like a whole plethora of things. This was like a kid in a candy store. I walked in and my eyes just opened up, and he goes, remember, everybody was just fired on this project last week. So they had a lot of new people in. The plumber was like, I don't even know. He goes, I just want to start over. But he had to dig all, like he was chipping out all this plumbing because it was all in those walls. They had to redo those. I mean, it was a nightmare. But it gave me some great examples of, can you believe this? If I talked about this, you probably would be like, hey, Hope, you're telling a story. Nope, here's the one. How about this one? What do you think? Just in case you're wondering, here's where it starts, comes here. It gets crammed between this, and then it continues on. Whoop. What do you guys think? How many of you think it's going to be just fine? Anybody think that maybe they might have a conversation with them? I can't tell you how many times I go out and I see crumpled, crimped, smashed ductwork, and they're like, it's fine. I'm like, no, it's not. Do you know how stupid air is? I said, you're not going to get the CFM where it's going to go. And now that they have to test it, they're going to start seeing all of that. Anybody have failed ventilation tests being provided to them? All right. All right. We've talked a lot about manual J, S, and D, right? So this is one of those fun ones, right? So the manual J criteria has been in the code since the very early, and I mean early 1990s. We're talking uniform code days, right? It's carried on into the I codes. You find it called out on the residential code since the very first edition of the residential code, which was what, the 1998? I think that was what it was for IECC. And then came along in the energy code. The energy code isn't necessarily concerned, it is concerned with doing the heating and cooling load calculations, But you have to have that to ensure that you have your equipment sized appropriately, which is what the energy code wants to have, because that's how we have energy efficiency, right? So heating and cooling equipment has to be done in accordance with Manual J, and then the sizing done in accordance with Manual S. So when we're reviewing for a Manual J, these are the things that, really hit home for me, that I always ensure are correct, right? And it might seem done, but the location, I've had projects given to me that it's the incorrect location. Not that big of a deal, but it happens. And I make sure the outside dry bulb and wet bulb are correct, and that the design temperatures and humidity are correct. And I also make sure that all the construction descriptions that are placed in that Manual J match what we have as far as our thermal envelope on our construction plans. I also, if they have an energy report because they went with the compliance path that has that, I'll also make sure that it matches that. Because if we don't have that, we can't ensure that everything has been designed correctly. And here's how it goes, because I have a lot of people that say, oh, that person who is who did the Manual J is trying to pull a fast one on me because the items in the construction description don't match what's on the plans. And I'll admit, a long time ago, I thought the same thing. I'm like, they're messing all this up on purpose, trying to get bigger equipment. But what I have since then learned in my younger days is the fact that the process that happens is everybody comes together at the beginning of the project. Architect, whoever's doing the energy stuff, and then the Manual J, whoever's doing the Manual J. They decide, okay, so this is the components of my thermal envelope. And they all work from that. So the person doing the Manual J supplies the report. Well, the energy person and the architect decide, well, we need to switch things up on our thermal envelope. They very rarely ever relay that information to the person doing the Manual J. Person doing the Manual J usually doesn't know until they get review comments, and then they're like, how come you didn't match all these things? Well, you didn't give it to them when you made the changes. And so just be aware that's usually what we have going on there. So, this is really what we want to make sure. Like I said, we want to make sure that everything matches up so that our occupants have a comfortable home and that the equipment is sized appropriately. Yes. What I have suggested in the past, because when I talk to a lot of architects and designers in the whole conversation with this, is I understand that especially residentially, you're going to be going back and forth because if it's for a homeowner and not a tract builder, there are things, minds change a lot in the whole scheme of things. So, okay, so you find out that this is what you're going to do as a basis for it. Usually in the software and everything, you have everything built out. All you have to do is go back in and change, the windows are going to be this now, right? When you go back into the system. But it is an additional step, and I don't disagree with you on that. But what they do need to do is once it's finalized, all that information needs to be provided to you, because that skips a whole lot of review comments. Because I'll tell you, I have had to make review comments galore on Manual J's because they don't match up. And it wasn't necessarily that the Manual J was bad. It was that the description criteria doesn't match. And then I don't know whether the equipment is oversized or undersized because there's just so many differences that happen with it. So I know there's going to be changes, and I know that they start off with it, but the information does need to get passed on.
And the insulator comes in and says, we don't do R27, we do R30. And then,
And then it changes it again.
on the fly.
Well, and here's the deal. I mean, if it's a wall, don't get me wrong, a wall has an impact on heating and cooling loads. It's not the highest impact on heating and cooling loads. If they had to change out ceiling or they had to change out the windows, oh heck yeah, then there's going to be a different discussion. A couple of R values in a wall is not going to make a big enough difference typically that the equipment's going to be, oversized now. If it's oversized, I'm going to say it's oversized by 10 BTUs type of deal. So, all right. So here's our lovely efficiencies, because basically what this tells us, right, we know the equipment size and making sure it's all good, but we also have to make sure that we have the minimum efficiencies that's required for the location. Now we have in a manual J what efficiency they're wanting to do, but we don't necessarily have it here. So what we have to do is take a look at this, and it gives us our efficiencies. Now it's going to be dependent on the type of equipment as far as the information that's provided here. Typically it'll say what type of equipment it is up here. It gives us what our manufacturer's model and product is. This is where we get some of our efficiency ratings out of. And it also shows some other information. This says that, hey, here's an Energy Star one. So here is one for a heat pump. So here is our seasonal energy recovery. That's our SEER, right? So that's for our cooling. And the cooling is saying that it's a 15 SEER. So this is the information for the make and model. This is saying heat pump, cooling, heating, split system. Here's our heating. This is our HSPF, and it says 8.2. Now this is not saying whether or not it meets the criteria for our location. All it does is provide us with that particular information for that piece of equipment. Now here's different ratings. Anybody know what these indicate? Those are the locations that that piece of equipment is actually permitted to be installed. So this says the federal law allows this unit to be installed only in these locations. So if it didn't list Colorado in here, we should not be seeing this piece of equipment being installed in Colorado. How many of you knew that? How many of you were like, this is the one thing I learned today and I'm really excited about it? All right, woohoo! Now this is important because remember there's that additional efficiency criteria that comes in with all of that. A little bit about residential mechanical systems. Let's talk about when we have some multifamily projects, because sometimes we have multifamily projects or systems that are serving multiple dwelling units, right? We don't have that individual mechanical system. It's one system doing all of them. What the residential code says is, hey, by the way, jump on over into the commercial section of C403, which deals with the mechanical, and C404, which deals with the service water, heating, and plumbing. So it just says go and follow those provisions. Now, as you'll notice, these provisions are not all that different. You got heating and cooling load calculations, just like we have on the residential, right, for our mechanical systems. You got to ensure that you size it appropriately, like a manual S, but this one is for commercial. You got to make sure that it meets the efficiencies. Now it's a little bit more complicated than residential, but still the same concept for it all. So there's a lot of similarities. It's just we know that commercial typically is a little bit more complexity to it. And so it sends you over to that. Yes, Derek?
Well, we sometimes run into that as when we have commercial that's converted into residential.
Oh.
So if they have, for example, like forced water heat, let them share that as long as they can zone it per unit. But don't let them share the air.
So here's the fun thing. When we're talking about existing buildings, we actually don't start in Chapter 4. We start in Chapter 5. And Chapter 5 tells us what provisions out of Chapter 4 we have to comply with. Now, because it's a change of occupancy, you basically are treating it as if it was a brand new building. But I had to throw in the Chapter 5 conversation with it.
So for building permits, we should be receiving Manual J, Manual S, and even Manual D.
At plan review?
Yeah, at plan review.
Mm-hmm.
Or can we get that at mechanical review? I guess we need it for plan review, for building permit reviews.
Yeah, I would get it at the, at submittal. I'm not sure, do you divide it up where they have a mechanical submittal, a building submittal, plumbing
Correct.
submittal?
Usually we receive building permit submittals, and then MEPs, the contractors, just do that later.
Well, I would say that what you need to be able to show for the energy code, if nothing else, the MEPs would need to be provided because we haven't even hit all of the criteria for the energy code. So I would say those probably do need to start being submitted for that at the building permit phase and not as a deferred submittal or a as-built.
Right, okay.
Snowmelt systems. Anybody have snowmelt systems here? All right, so if we have a snowmelt system, the energy code doesn't say you can't do it. What it does say is you will need to have controls on it. That control needs to basically shut everything down when the pavement is 50 degrees or warmer and we don't have any precipitation falling and the outside temperature is at least 40 degrees. Now it does talk about right now that it can be automatic or manual with that. So typically it's this type of system, right? We got the sensor going in that gives us all of that fun stuff. Now what about pools and spas? Do you guys get a lot of pools and spas residentially?
Yes.
All right, so there is criteria in the energy code to address pools and spas. So first thing is, heaters have to have an on-off control. Now it can be integral to the heater itself. It can also be external, but it has to be within 3 feet of the heater. It also has to be in a ready access location. So if this was the heater, again, it couldn't be up there because that's not ready access. So it's got to be within that 3 feet and in a ready accessible area. Now, one thing is when you have the switch, whatever it is, it cannot change the setting of what that thermostat is. You also cannot use a circuit breaker as your switch for this. If you happen to have a gas-fired heater, you cannot have a continuously burning pilot. Now, with all of this being said, realize that I knew we had a lot of communities here that have outside energy use programs and all of that. I did not include that in here because I thought it might get confusing since each jurisdiction kind of has their own. So I omitted it out of it, but I understand that all of that we're talking about right now kind of plays into that. The other thing is, you got to have a time switch or some sort of other control for it, and you're going to turn off the heaters and the pumps on a schedule. Unless, of course, public health says it's got to be on 24 hours. The built-in switches have to comply with what it says here. Now, it does also have that pumps that operate on solar and waste heat recovery heating systems. The waste heat recovery system is that drain that preheats the water, right, with all the copper wrapped around it. That's what they're referring to here.
Well, we actually have a really big one that we run our pool off of in our rec center.
That has that?
It has an 8-inch main that comes in, and that's the transfer.
And it has the heat, oh.
It comes from the waste.
Oh, does it?
treatment
Oh,
plant.
okay. Oh, okay, so it's similar concept.
So, yeah, it can be, you know,
I got really excited that you had that design going on. It's still good, it's still good.
At the treatment plant.
It just comes down and,
Yeah.
that's
But,
awesome.
Derek, tell me if I'm wrong, but the bacteria causes heat during the process.
yeah, they can generate like 60 degrees temperature out of the wastewater treatment irrigation basins, and then that gets piped over and through a heat exchanger, and then they have a boiler to bring it up to temp. And we're actually going to share it with a new building that's going to be constructed next to my office, and it'll be used to heat the underground parking.
Oh, nice. I'm going to be very interested to see all that. So I'm hoping Derek remembers that pictures are always welcomed. If Derek didn't hear, you heard me at least say it. All right, what do you guys think about this system? Would something like this meet the criteria? Yeah, why not? It has everything listed on here. And in fact, most of the time, that's what I'm seeing being called out on plans and being utilized. That, what is it, Pentair? I think that Pentair. Of course, Richard is going to give me a hard time because I said it wrong. And then here's a fun one. So pools are required to have a vapor retarder cover unless you utilize 75% of the energy for the heating comes from a heat pump or on-site renewable systems, and the operating season has to be for at least 3 months that that's happening. Anybody have that going on, or are they just installing pool covers?
A lot of them have the automatic pool covers.
Has anybody seen that stuff that it's like a film and you walk on top of it?
Oh, there's covers you can walk on.
We have safety covers you can walk on.
Well, no, this is like, it's like this. This is what gets me a little concerned. I guess it's like this material or whatever, but it's like a weird chemical thing that happens. And so it gets placed like on top of the water, like it's a boat on the water, and then you can walk on it. It's some sort of barrier thing. Somebody was showing me it, and I'm like, because I think of safety or whatever, and I think, well, I don't want my grandkids walking on that thing. And I suppose it's all a matter of trust. And it's been around for 1,000 years. I'm like, I'll take this sucker. That works.
You can't walk on that.
You can't walk on that. But you know what? When that's out, nobody thinks about it. They're like, oh, the pool's covered. You see that stuff on top of the water. What are they going to do? Oh, I want to walk on water, right? Maybe it's just my grandkids that are crazy like that. But
I mean, there's ones that deer and horses can walk on.
really? All right, so here's the fun thing. How many of you have adopted the International Swimming Pool and Spa Code? How many of you have adopted the Energy Code also? Guess what? There's a conflict between the two. Anybody aware of this?
No.
Are you guys like, ooh, I learned 2 new things today? All right, so if you go with the International Swimming Pool and Spa Code, it says for the exemption for the cover, it only requires 70% of energy for the heating, and the pump has to be an on-site or from a heat pump or on-site renewable, whereas the Energy Code says 75. So which one do you make them do? 70 or 75? More stringent, but doesn't each of section 1, chapter 1 of the code say whatever is more stringent, but this code applies, right? So which one of this code applies do you listen to, right?
Sure, you put a dart, you put something on the wall and you throw a dart and whichever one it lands on.
Is that the one that you do? Well, I only bring this to your attention because the reality is if you don't have the dart system in place, then you probably want to have a policy that says, hey, we're going to follow what's in the Energy Code and not what's in the Swimming Pool and Spa Code. Or at your next adoption, make sure to either make sure that they correlate with each other.
Stay in your lane, Hope.
Hey, it's all my lane, remember? I weave all over the place. All right, portable spas, they have an energy requirement too. They just have to comply with APSP 14. Now, residential pools and permanent spas, the energy consumption for these, have to meet APSP 15. So if it's portable, 14. If it's in-ground or permanent, it is 15. All right, let's talk about lighting. So all of your, okay, anybody have any more questions about mechanical before we jump to lighting? Okay. Lighting. So all your lighting have to be high efficacy bulbs. That definition has changed, so just be aware of that. Although I don't know of very many people or manufacturers that are manufacturing things that are no longer permitted by code, but that doesn't mean that there isn't new or old stock in play. By the way, that is not an energy code criteria. It's a federal efficiency change that happened with that. Do what?
State laws.
State laws complying with what the federal mandate is. Now, it does talk about kitchen appliances are exempt from that. So the light in the refrigerator, the light in the stove, all of those are exempt for the time being. All right, so I wanted to make sure you were aware this is the new definition for high efficacy light sources. Oh, I thought I had the other one in there too, but never mind. This is the new definition for high efficacy. All right, let's talk about exterior lighting. So exterior lighting has to comply with what we're going to talk about here. When they're talking about this particular section, this is not pertaining to the single family, two-family townhouses. This is basically referring to exterior lighting for R2s, R3s, and R4s that are 3 stories or less. Now, there are some exemptions from what I'm going to talk about, and that is, again, if you're townhouse, single family, two-family, but basically if you have solar-powered lamps, and it's not connected to an electrical service, if they happen to be, if the luminaires are controlled by motion sensors, and if they happen to comply with this section here, that they all have high efficacy bulbs. Now, what you're going to do is it then sends you over to the commercial section and says treat it like commercial, meaning you're going to do lighting power density and those fun items with that. So basically you would take this and you're going to follow this. I'm going by it quickly because we already talked about this last go around. But basically here's all your parking stuff. You're going to do an exterior lighting compliance certificate, and this meets the criteria out of the residential section. So in the 21, instead of bringing all this over into the residential side, they just say, hey, go follow the parameters out of the commercial, and we're going to call it good because you are a quote unquote kind of a commercial building in this aspect. All right, so your day lighting, what it also has to have is shutoffs. So it's automatically got to shut off when the daylight is present. It's going to shut off 1 hour after it's closed to 1 hour before. And then you have your setbacks. It's going to get reduced by 30% from midnight to 6 a.m. or 1 hour after closing and 1 hour before opening, or when there is no activity for 15 minutes. This is still criteria out of the commercial side of the code that it sends you to. Now, jumping back over to the residential side, see, you guys are getting so much exercise between raising your hands, jumping from the commercial side, going back to the residential side. So you guys don't have to go to the gym tonight. All right, so, huh?
Yeah, I do.
Except for Derek. Derek has to. All right, fuel gas lighting equipment. It cannot have pilot lights that are continuously burning. This whole thing went away for a while. I saw it a lot, and then it went away. Well, it's coming back in. Everybody's doing gas exterior lighting now.
I just
So.
did a remodel on a house that has them all over the house.
Oh, really?
All over the outside, and they run 24/7.
Yeah. Yeah, this was plain day. It's still going like crazy. All right, now let's talk about our interior lighting controls. So you are required to have controls. It has to be controlled by the following: a dimmer. Here's how the code is defining a dimmer: device that's capable of continuously varying the light output and energy use of that light source. An occupancy sensor. An occupancy sensor is this definition. I won't read it to you. You guys can all read it. or other control installed in a fixture. So that could be a lot of things. So it could be built into the fixture, right? We have these instead of a separate sensor. There's a light that has a vacancy sensor or an occupancy sensor built into it, right? So, yeah, we'll talk about that in just a moment. Now, there is some exceptions here. Bathrooms are not included. Hallways are not included. Exterior lighting fixtures, but don't be worried, it has its own section. That's why it doesn't have to comply here. And then lighting designed for safety or security. So when they talk about lighting designed for safety or security, this is not, I need lighting on the stairs because Hope is a klutz and we don't want her in her own home to trip up the stairs to go to the bedroom. What they're referring to is, if you think about it, R2s, R3s, and R4s that are 3 stories or less are going to have to comply with this. What is something that R2s, R3s, and R4s are going to have that a single family, 2-family, and townhouse is not going to have? Exit stairs. So we're going to have those exit stairs, right? And so that's what they're referring to as far as safety, security, not having controls on those stairs, right? Ensuring that they're on and they have the correct parameters. Think about corridors, right? So those are a little bit, those are kind of exempted out of it through this. And I think rightfully so. Now, on the commercial side, they did take care of it, and I think they took care of it for corridors in a great fashion. It didn't translate over onto the residential side for those R2s, R3s, and R4s. They're just kind of exempted out for safety and security. So here is what I'm going to ask you. I'm going to ask you if what I show you on the screen, if that meets the criteria of the items I just showed you. Would you accept this? Is this a dimmer, an occupancy sensor, or something built into it? You would accept that? This is one of those that there is no wrong answer and there's no right answer on this, like per code. This does become a judgment call, but it is a judgment call in the reality of energy efficiency because these are being called out all the time. So you have to make that determination for your jurisdiction. What about this one? This has a remote to it. You would accept that?
So other control within the picture?
Whoa, say that again.
Looks like you can dim it.
Does look like you can dim it.
It's considered other control within the picture.
Other control within the fixture. Again, like I said, no right or wrong on it. This is something that you all will have to kind of determine and figure out. What about this? Alexa, would you accept that? Now this is what I'm going to ask the question to you for. With these types of systems, do they stay with the home when the home moves?
No.
Or I mean, when the people move from the home, if the home moves, maybe not. If the people leave that home.
Probably going to go with the people.
Probably going to go with the people. So at that point, this system would.
But like Avon would not.
Yeah, no, I would say this one would stay. Even this would probably stay because they would just have to download the app. This is a separate item that has all of the other components, not just their life of the lighting system. They're probably going to take it with them because it has their playlist. I don't know what all Alexa has, but I know that there's a lot of people, like my brother uses it for everything. So I know it has a lot of it. And if he moved, he would not be leaving that Alexis. So This is me personally. I don't think Alexis meets that criteria because it's not going to stay with that structure itself. So looking at these plans here, what do you guys think? I'll give you a second to look at it. Do you think we have the controls needed?
Kitchen's not there.
Kitchen's not there. Good job. We got all of this shown here as far as motion sensors, which is occupancy sensors, vacancy sensors, and then the kitchen didn't contain anything in there. Now, what about when we look at this? This is something when we talked about safety and security, I really should have put this up there with it, but these are the areas that I would feel incredibly comfortable, and of course, I love the energy code, that if they said, no, this is for safety and security, we don't want these on a dimmer, we don't want them on occupancy sensors, I would agree, because it doesn't have the criteria that the commercial side has to ensure that there is some safety and security with it, right? Because on the commercial side for corridors, they don't reduce down to 0, right? They don't just shut off. It reduces by 50%. This doesn't have any of that same criteria. It's just that this is what it has to have, one of those things. So we want to make sure that we have that there.
Those lights have to see that.
Unless they fall under commercial, then commercial corridors, other than stairs. Stairs in the 21 are still exempted out of that criteria. So what about, or here's our fun with our exterior lighting controls if you're single family, 2-family townhouse situation. So the first one is that if you have a total of all of your lighting for your exterior equals or exceeds that 30 watts, then you're going to have to do all this. So it's got to have a controlled on-off switch that allows for automatic shut-off. And then, except for lighting that's serving multiple dwelling units, and I say that because sometimes you have a 2-family where for security, like you have like exterior lights that are on, but they're not controlled by the occupants. They come on at night type of deal. So except that lighting that's serving multiple dwelling units. And then the other one is lighting shut off when daylight is available and there's enough light. Today we don't need the exterior lighting on, so there has to be some sort of control that's going to shut it off right now because we get plenty of light from that sun. Next one is we also need a control that's going to that overrides that automatic shut off. And what it does is you can, like, something happens, you need to have that light on for whatever reason, so you have that light on, so it's that overriding what the system is requiring, but it has to return back to the, like, basically what I want to say, it's normal programming, right, once the event is over, right? Maybe I was trying to think of something right now and I can't think of it, but you're working on the electrical system. Well, you wouldn't have the lights on if you had the electrical system. I don't know. I can't think of anything right now because I want to tell you an example of this. But anyway, you have to have the ability to override it, but within 24 hours, it goes back to its regular programming. So would you guys accept this? It's on a timer. Would you say that meets the intent of what is being asked of it?
Yeah.
It's probably set where when it's daylight enough, it's going to shut off. It has probably a switch because it shows a switch somewhere. Or maybe not on this part of it. I probably cut it off, but it does show an on-off switch. So the only thing it would have to do is go back to its regular programming within 24 hours. And I think the timer would do that. All right. That's the end of the lighting part. Now, this is your little bonus because we didn't kind of include it, but it is something that you all have to be aware of, is the fact that in the 21, right, we have additional efficiency criteria now. So in this instance, a project only has to pick one and then consider it to be completed with it. So the first one is you're going to have an enhanced envelope performance option. And this one talks about that basically you're going to show that your design is 5% better than what the standard if you went prescriptive would be. So for your going with ResCheck, you're going to show that you're 5% better than what the code requires. Now this one, just FYI, this is going to be a little bit more difficult to get that 5%. It would have been fine, and everyone's like, well, how come we have this, and then they pumped up the table for the thermal envelope. So there were people that worked out of additional efficiency saying, hey, let's leave the table alone and we'll just work on additional efficiencies and leave the base alone. And this is where a project can pick it and make it more kind of customized to what they're doing, as opposed to saying everybody has to do this. And then there were people that said, no, let's do the table. Well, ultimately in CDP Access, where all the voting governmental members could go in and vote on the code changes, both of them passed. So where this was saying, hey, you just got to be 5% better no matter how you want to get there on your thermal envelope, and we can call it good. So this one might be a little bit difficult, only in the sense that our walls went from an R20 to an R30, or an R10 continuous with an R13, and now we're an R20 with an R10 continuous, right? So this one may be a little bit more difficult to do, but it's not impossible. Now this one, the second one, kind of ties into what we were talking about today, which is more efficient HVAC equipment. And this is the criteria that's set into here. Now, when this was put together, this was before the federal minimum federal efficiencies were changed, right? The testing standard that they all had to utilize changed. So even though it says SEER, and that's referring to the SEER 1 or the original SEER, and now everything has to be SEER 2, just think of the 2 afterwards on it. So it says, depending on whether you're going to do a gas furnace and an air conditioner, if it's a gas furnace, it's 95 AFUE and a 16 SEER. These are the minimums. If you're going to do with an air source heat pump, it's got to have a minimum of a 10 HSPF and a 16 SEER. And then if you are doing a ground source heat pump, then it has to have a COP of at least 3.5. I think this one is probably a pretty good one, because a lot of projects that I see around Colorado are doing the 95 and the 16 SEER anyway, so it could be an easy one to kind of comply with, or it's not such like they're starting off with an 80 AFUE furnace. They might be at a 90 or a 92, so they might make that jump for it. This is something, if that's what they choose, we're going to have to be very thinking about when we come to that manual J. It's got to be very explicit, and we have to pay attention to it because it'll show the efficiencies on the manual J, right? And then we're going to have to make sure that we verify it out in the field. Now, this is one that I think when we start talking about that we don't discuss often on the residential side. There's very little plumbing or anything of that nature in there besides, hey, insulate your plumbing, or have a couple of controls if you have some demand response circulation in there. So this one talks specifically to the water heater. So what you're going to do is ensure that the efficiencies of the water heater, dependent on the type of water heating system you're going to utilize, meets this particular criteria. So fossil fuel, it's 82 EF. I know that should be UEF. If it's electric, it's 2. If it happens to be solar water heating, then you're going to have a solar fraction that's at least a 0.4. Anybody have solar water heating here? I kind of thought we might have something like that. You did it on a project? So just remember, it might work. I don't know. For the pool. Oh, but that would be commercial, not residential. Oh. Well, that could be residential then.
18,000 square feet.
That's still a house. That's still a house. It's not my house, but it's still a house. So this is something like when we're out in the field that we're going to have to verify that it actually meets the criteria. If they call it out on the plans, then it should be followed through with what we see out in the field. Now, this is the one that I was alluding to earlier. And this is demonstrating that you have 100% of your ducts or whatever your thermal distribution system is going to be located inside your thermal envelope, inside conditioned space. That's why it's so important. When we spoke earlier about 403.3.2 and 403.3.3 and ensuring that we can make all of our ductwork be inside conditioned space because it helps us with this particular option. Now I know a lot of designs in Colorado are already, or in a lot of places in Colorado, are already putting that ductwork inside the thermal envelope. Or they have a little spot, or they just would have to do small little tweaks to make sure that it's completely inside the thermal envelope. So this one I think is a little bit more readily available, where maybe it's not as contentious as some of the other options there. So this one, of course, we're going to want to pay attention to it, but the big thing is taking a look at that manual D. That manual D is going to really let us know whether or not we can do it. Now, here's one that I think would be a good one for all of you up here that have to have an ERV or an HRV, so Climate Zone 7. Climate Zone 6, this is still a really good option if they're doing balanced ventilation. And what this is basically you're going to have improved air sealing and install ERV or HRV. And so you're going to do a blower door test. It's going to be less than 3 air changes per hour. And then you're going to install an ERV or HRV. And for us, what we're going to do is it's going to demonstrate that it has a sensible recovery efficiency of 75% at the 32 degrees for it. Ooh, excuse me. So where the other one was 65%, this one is a little bit better, meaning you have a little bit better performing of a HRV system that would go in. Yes?
Can you take this if you're applying Climate 7? Is ERVs required?
Yes, because the big thing is the sensible, yes, exactly. Because of the sensible recovery efficiency, it's, I think it's 65%. It might be 68%.
68.
At the 32 degrees, if you're just installing it, that's, if we're putting in an ERV or HRV, it has to do that. If we're going to show that we're doing it a little bit better and utilize this option, then instead of the 60-something, it has to be 75. Which honestly, nowadays, what I see out there being installed is already the 75. But whether that was a conscious choice or that's what was available, I don't know. So this is one I think could be a good one. Oh yeah, so here's an example. Did I blow it up? There we go. So does this one work?
Does not.
So we have to look at the sensible recovery efficiency. This is what we're looking at. It's got to be at least 75% at 32 degrees, and it usually says at the lowest. So we're going to look here, 32 degrees, it's only at 68%. So it would meet the base code, but it does not meet to qualify as an additional efficiency. It has to be a minimum of 75. All right, ladies and gentlemen, that comes to the end of the day, and I apologize for being a little early, but because we couldn't get the videos to work, I set it up that we would see videos, so I am so sorry. You'll get full credit for the class and everything, so just because we're a few minutes early, that, don't worry about that. But anybody have any questions, thoughts, comments?